It's our nearest neighbor, the second brightest object in the sky. We know that moonshine is reflected sunshine, and that men have walked the lunar surface. Yet the moon retains its mystery. Where did it come from? Could we live there? In search of clues to our only natural satellite, we fly to other moons and other planets. At the edge of the solar system, the planet Pluto and its moon Charon. Time-lapse pictures from the Hubble Space Telescope. Here in simulation, they're barely 12,000 miles apart. Pluto is the tiniest planet, smaller than our moon, and just twice the size of Charon. Strictly speaking, Charon doesn't orbit Pluto. They're both in orbit, around their common center of gravity. Are they a double planet or a moon and planet? And is this a moon? We used to think only planets had moons, until this rock was discovered in orbit around this asteroid. The asteroid, called Ida, is 35 miles long. The satellite, Dactyl, less than a mile across. Tiny Dactyl is possibly a chip off the old block, split from Ida in some ancient collision. As to whether it's a moon must be left to astronomers. But when is a moon not a moon? Must a moon be a sterile satellite? What if it heaves with activity? The solar system abounds with companion worlds. Take Io, where volcanic plumes spurt 200 miles from the surface. Bigger than Pluto, Io really is a moon. The discovery of its eruptions were a sensation in 1979 as space probes visited Jupiter. Of the 9 planets, 2 have no moons, those nearest the Sun. Closest of all, scorched little Mercury is itself barely the size of a moon. It's been inactive for billions of years. By contrast, Venus swirls with the turmoil of an ugly weather system. But Venus also travels alone. Not so for the giant planets. This is Jupiter and its entourage of moons. Fifth from the Sun and largest of the planets, Jupiter has 4 moons bigger than Pluto. In all, there are 16 Jovian moons. From Voyager, 2 of the moons. And their shadows. Launched in 1977, the Voyager probes 1 and 2 took 2 years to reach the moons of Jupiter. There was Callisto, outermost of the big 4. The roughest of the moons. Impact craters everywhere. The greatest feature, Valhalla, a basin 1,900 miles across, here in an artist's impression. Like a fractured windshield, Valhalla was blasted by an impact from space billions of years ago. Elsewhere, smaller craters crowd rim to rim. They're evidence of non-stop bombardment during the early days of the solar system. Callisto has remained frozen in time. Callisto may look like our moon, but its craters are brighter, for this world is little more than a ball of ice with a rocky core. Inward from Callisto for a flight over Ganymede. We're skimming the biggest moon of the solar system. Craters aplenty, but curious wrinkles. They're thought to be fault lines where water has broken through and frozen. At minus 390 degrees Fahrenheit, Ganymede's surface is an icy crust 200 miles thick. Beneath it, a mantle of slush overlaying a rocky center. Unlike Callisto, Ganymede has evolved. The view from Ganymede is majestic. Jupiter dominates the sky. Until Voyager, we didn't know Jupiter had a ring, a dusty halo like talcum powder. The bright dots orbiting in the plane of the ring are more Jovian moons. And there goes the sun, out here, little more than a star, 500 million miles away. The third of Jupiter's big moons is Europa, a moon like an egg. Smooth and uncratered, Europa is probably a gigantic global ocean, thinly covered with ice. Such patterns occur on Earth, where the sea repeatedly melts and freezes. If there's other life in the solar system, it'll be here. In the 21st century, robot submarines will no doubt plunge beneath the ice to seek it out. Life on Earth began in the oceans. Today it teems in the waters of the Arctic and Antarctic, so why not in the seas of Europa? It's a tantalizing prospect. Were Jupiter a star, Europa would be a planet. Instead, it's an egg waiting to be cracked. Whether there's life inside, only time and astrobiologists will tell. Of all the Jovian moons, this is the most exotic. We're looking at the surface of Io, innermost of the Big Four. At first, it baffled scientists. No craters, no ice, more like a pizza. But as the Voyager pictures came in, the geological truth was out. The blush on this moon is sulfur. Voyager was peering at the most active volcanic body ever seen. Eruptions everywhere. Volcanoes the size of Colorado spew monumental plumes. The entire moon is in upheaval. Io is turning itself inside out, over and over again. The gravitational pulls of Jupiter and Europa. Io is like a tennis ball being repeatedly squeezed. The result is tremendous internal heating and eruptions from every crack on the crust. Io's moonscape is nothing but sulfur. Uranus, seventh planet from the Sun, a giant with 11 rings. They were counted when Voyager 2 passed this way in 1986. Against the blackness of space, the rings are difficult to see from Earth. Voyager discovered their makeup. icy particles from specks of dust to boulders the size of a house. The rings may be the remnants of shattered moons, the debris of an impact with a body the size of Earth. The same collision may have given Uranus its peculiar tilt. The axis of the planet is 98 degrees off vertical with respect to the Sun. Out here, the Sun is that point of light beyond Voyager. The rings in close-up. A couple of moons. The images were coaxed by computer. In reality, the rings are jet black. Uranus has 15 moons. In 1989, the saga continued. Voyager reached distant Neptune. No one knew if Neptune had rings or just partial rings, arcs. Voyager targeted them and solved the mystery. Indeed, Neptune has rings. The arcs are simply the thickest parts of the rings. In all, the probe confirmed 5 rings and 8 moons. But it was a sideshow compared to Saturn. Of all the planets, Saturn is Lord of the Rings. In the early 80s, Voyager ended centuries of speculation. The astronomer Galileo had spotted something in 1610, but 50 years elapsed before they were identified as rings. Until Voyager, astronomers thought Saturn had just 6 or 7 rings. In fact, there are 7 main bands, each comprising hundreds of rings. Voyager not only proved the rings weren't solid, it identified their nature. They're formed from billions of icy particles, a heavenly mixture including silica rock and iron oxide. Edge on, Voyager time-lapse shows the gaps between the main bands of rings. Animation reveals a single ring, a host of orbiting moonlets the size of automobiles. Beyond the rings, Saturn boasts 18 moons. This is the largest, Titan. Orbiting more than 750,000 miles from the great gas giant, Titan has a smoggy orange atmosphere, 1.5 times denser than our own. Titan is bigger than Mercury. It's a world of methane lakes and hydrocarbon snow. It could be Earth in deep freeze. The chemistry of Titan today may be the mix that prevailed on Earth when life emerged. En route for Saturn early in the 21st century, a spacecraft named Cassini will check out Titan. Cassini will release a robot probe that will penetrate Titan's shroud. Packed with sensors, it'll provide information denied Voyager. There'll be a soft landing. The probe will sniff out possibilities. Could humans land here someday? Back in the 80s, as Voyager swung by Saturn, its smaller moons yielded clearer images. One of them, Enceladus, was just 120 miles across. Courtesy of Voyager, we can now explore its split personality. Heavily cratered in places, Enceladus is smooth elsewhere. Water seems to have burst through fissures and frozen. Like Jupiter's Io, a case of gravitational flexing. Outward to Uranus, and the craziest moon. These are Voyager's pictures of Miranda, a moon like a diamond in the rough. Miranda is geological activity gone mad, a random assembly of glaciers and canyons. And weirdest of all, these ice cliffs, 12 miles high. Imagine standing beneath them, gasping at the colossus of Uranus beyond. If you jumped from these cliffs, thanks to minimal gravity, you wouldn't hit bottom for 12.5 minutes. Planet Neptune, and Voyager switched course for its biggest moon, Triton. The probe fired its jets to align carefully for the sharpest photography. Triton looked odd. It had mysterious crisscrosses, frozen eruptions, the coldest known surface, dark streaks. And oddest of all, with its trail outlined in black, a geyser of nitrogen. The sun is 3 billion miles away, yet it's strong enough to melt Triton's icy surface. From beneath, nitrogen jets escape. They spurt 8 miles high and 150 miles downwind. Triton is extraordinary. So too is the variety of moons. The solar system has hundreds. Our moon. In comparison to the more exotic moons of the solar system, it's placid. The moon is average size. It would fit comfortably across the United States. The moon always presents the same face to Earth. We never see the other side. So even when only part of the moon is lit, we see the same features in the same place. The moon is barren, inert, and airless. By day, temperatures peak at 250 degrees Fahrenheit. By night, down to 200 below zero. In 1994, exploration of the moon resumed. A tiny probe called Clementine mapped its surface as never before. These are Clementine's pictures, swaths of pinpoint images as the craft orbited the moon. We're over the crater Antoniadi. Dug by an impact from space nearly 4 billion years ago, Antoniadi is 100 miles across. Smaller, more recent craters are embedded in its walls, preserved in the vacuum of space, unchanged by wind or water. At the south pole of the moon, Clementine captured this time-lapse sequence. In close-up, there are long rotating shadows. As the moon turns on its axis, they're cast by sunlight slanting off the rugged terrain. Another spacecraft, Galileo, took a slingshot path by the Moon and Earth in 1992 to gain momentum for a voyage to Jupiter. As it did, Galileo gave us a new perspective. For the first time, we saw the Earth and Moon moving together in space. Both Galileo and Clementine captured images of the Moon with special sensors. They produced these pictures. Color-coded, they show the different minerals of the lunar surface, a prospector's guide. One day, no doubt, we'll mine the Moon. Clementine gave us the first detailed views of the Moon's polar regions. Thanks to computer enhancement, we can fly over these twilight zones. Like most of the Moon, the poles are cratered, evidence of the storm of missiles that bombarded the early solar system. The Moon itself may be the remnant of a collision with the newly formed Earth. Someday, decades ahead, we'll sail spaceships to the moons of the outer planets. We'll take excursions to the ice moon, Triton, and wonder at its planet, Neptune. And at the very edge of our system, we'll lift the veil on Pluto. Is Pluto a double planet or a small planet with a big moon? We'll know in the 21st century when the first probes arrive.
Is there life?